Hi everybody, this is Pam Price with PamTech Coding. And if you are looking to improve your coding skills and particularly your problem solving and debugging skills, then you are at the right channel. I want to talk today a little bit about debugging because when your program does not work, it's important for you to be able to figure out why. And it's not a guessing game. It's actually something you have to dig in and figure out. So I have written here a very common example of a problem that you will see, which is write a function to calculate and return the sum of the integers from 1 to some number. You'll notice my code has no comments in it. That's actually an indication of a problem because I think you need to write comments and think through the problem solving steps before you write code. But let's just say you were feeling confident. You say, well, I know I need an accumulator. I know I need a loop to go through the numbers. I think this is the code. Let's just run with it, okay? All right, so in order to test it, you need a test case. And you need a test case that you know the answer to because your program may give an answer. Just because it gives an answer, it doesn't mean the answer is right. It is up to you to know whether the answer is right. So if I pass the number 3, then I'm trying to add up 1 plus 2 plus 3, and I expect the answer to be 6. Let's see what this code does. So if I go to my code here and refresh it, it is telling me 5. Okay, so it doesn't work. So what do? Do I just stare at it to try to figure out why it doesn't work? No. The first thing you should do is you should want to figure out exactly why this code gave that answer, which means you need to be able to read your code and walk through it the exact same way the computer walks through it. And to me, in all my years of teaching, I would have students do what's called a desk check. And that means on paper and pencil, you are tracing exactly what this code is going to do. And it's a really important skill to be able to do. So let us go through and desk check this code. So if I call calc sum with 3, then what I expect to be in the variable called num is 3. So you want to write down your variables and keep track of any changes in those values. You are basically mimicking what is going on in memory. All right, so we have another variable sum that we are initializing to 0. We have another variable count that we are initializing to 1. We go into the while loop. We check the condition. We have to look at the actual values. When you just look at words, count less than num, you don't know what that means without looking at what is the current value of count and what is the current value of num. So this test is going to be testing, is 1 less than 3? And that is true. So we're going to go into the body of the loop. The first statement here says count plus plus, which what does that do? That is going to increment count. This is going to become 2. It's very important when you do this desk checking, you have to cross out the old value and make sure you're clear on what the current value is. Remember, a variable can only have one value at a time. The next statement says sum equals sum plus count. This is an assignment statement. You go to the right side of the equal sign first. You look up the value of sum, which is 0. You look up the value of count, which is 2. So 0 plus 2 is 2. That becomes the new value of sum. That value is assigned to sum. Sum becomes 2. All right. We now are at the end of the loop. We go back. We evaluate this condition again. What's the current value of count? 2. Num is still 3. So we're checking whether 2 is less than 3. That is true. So we go inside. Count becomes 3. Sum is 2 plus 3 is 5. That is the new value of sum. we go back to here. What is the current value of count? Count is 3. 3 less than 3 is false. The loop ends, and that's why we are getting the value of sum is 5. So now we know why we got this value. But in walking through this code, did we realize maybe what part of the problem was? Remember, the very first time through, 1 was less than 3. We needed to add 1 to the accumulator, right? But what did we do? We incremented first, and that meant the value we were adding was 2. So we skipped the first number. So one of the things about an algorithm, sometimes you have the right statements, but if they are in the wrong order, then it won't work. Okay, so let's switch these. There is still one more problem that I want us to see. So we go, okay, that's the order that we need to have. Let's see what we get now. Now I'm getting 3. That sounds worse, right? That sounds like that's less close to the answer. Now I want you to understand something else. Just because that didn't work didn't mean that the change that we just made was not correct. We have just uncovered another error in this code. So let us desk check what we have now. Okay, so again, num is 3, sum is 0, count is 1, 1 less than 3 is true. Okay, so we're going to add that 1. 1 plus 0 is 0. That becomes the new sum. That seems like on the right track. Count becomes 2. We're going to test whether 2 is less than 3. And it is. So sum 1 plus count 2 is 3. That becomes the new value of sum, right? We increment count to 3. Now we're testing is 3 less than 3, and that's false, right? These were true. So the loop ends, and the value of sum is 3. So what's our problem? We ended the loop too soon. We need the condition to be count less than or equal to num, because we want this loop to operate when count is 1, 2, and 3. All right, so if we go over here now and we test it, we're getting that the sum is 6, which is what we want. Now remember, we actually want this to return the sum, kind of on purpose, because I had this console log in here right now. I wasn't returning it until I was sure what I wanted. So now I want to return sum. And if I don't change my function call, I won't see the answer, right? Because return is trying to hand the answer back, but there's no place to hand it back to. So if I want to hand it back and print it, then I need to now console log what the result of this function call is, right? And now I get 6. And if I change this, so if I change this to 5, then that would be 6, 10, 15. 15 should be the answer, right? Let's see if we get 15. Yes, and we get 15. Okay, now how would you avoid this to begin with? Talk yourself through the steps. What are the steps to solve this problem? I need an accumulator for the answer, right? What else? I need a variable to loop through the numbers from 1 to num. That's what count is, right? We set up the loop, set up loop to end when I get to num. And what do I do every time I get a number? Add this new number to the accumulator. And then we need to update the loop variable. Okay? If you were to write those steps first, then you would sort of clearly figure out how to do this. All right, but I want to do one more thing. Let's rewrite this with a for loop because it'll be shorter and you actually won't have the problem of sort of doing things in the wrong order. In this case, if we do a for loop. So if I use a for loop, remember I need to initialize my loop variable. So let count equal 1. I then need my condition, count is less than or equal to num. I then need my update, count plus plus. And what do I need to do in here? Add this number to the accumulator. Because in a for loop, it does the update as the very last thing at the end of the loop body, we don't have to worry about things being out of order, right? And I can even write this as plus equal. So I'm showing you a couple of little shortcuts here. So let's just make sure this still works. And yes, it still works. All right. So that is an alternative solution using a for loop. All right. But the real key to this video is being able to walk through your code. And ideally, what you want to do is to do this before you execute your code. When you sort of write out or test out your algorithm, you want to run some numbers through it first and make sure that you feel a certain level of confidence that this is the algorithm that is going to solve the problem. All right, so again, when your code doesn't work, the first thing that you have to do is understand line for line, what did you tell the computer to do? Because the computer is stupid. It can only do what you said. So if you will take more time on the front end before you actually jump in and just start writing code, then you will have more success in terms of writing your code. And if you have a problem that you're doing and you're just sort of staring at the computer trying to figure out what to type, that means you need to stop and problem solve. So that's what I'm going to talk about a lot in my videos. I always talk about writing comments. I always talk about coming up with the steps to solve the problem. That is the key to learning to be a good problem solver. All right, guys, so I hope that this was useful. And if it was, please like the video, please share it, subscribe to the channel, set up your notifications so you know when I post new videos. And until the next time, I want you to stay curious, keep coding, and keep learning. Bye now.